Have you ever wondered how to approach similar equations efficiently? When we have similar equations, there are two key approaches: addition and subtraction. But why are these techniques so powerful? Because they help us eliminate variables and reveal useful relationships. Let's see this in action with 2023 AIME II, Problem 4. We're tasked with solving for all possible values of x, given that x, y, and z are real numbers. The problem presents us with three similar equations. What strategies come to your mind when you see a system of equations like this? Now, let's get to work. If we subtract the first two equations and factorize the result, we uncover an intriguing product. X minus z times y minus 4. What does this tell us? It tells us that either x equals z or y equals 4. Similarly, applying the same logic to the other pairs of equations, we conclude x equals y or z equals 4, and y equals z or x equals 4. Do you see a pattern here? These relationships form the foundation of our next step. At this point, we split into three cases based on how many conditions from the first column, x equals z, x equals y equals z, are satisfied. Case 1, two conditions from the first column are satisfied. What happens when two conditions hold true? In this scenario, x equals y equals z, meaning all three conditions from the first column are satisfied. Substituting x for y and z in the first equation, we simplify and factorize. The result? X is either negative 10 or 6. Does this make sense so far? Let's keep going. Case 2. One condition from the first column is satisfied. What if only one condition holds? Without loss of generality, let's assume x equals z, z equals 4, and y equals 4. Substituting these values into the equations, we find that x equals 4 or x equals 11. Why do we assume this? Because it simplifies the problem and leads us to valid solutions without missing any cases. Case 3. No conditions from the first column are satisfied. What happens if none of the conditions from the first column are true? In this case, all conditions from the second column must hold. This implies x equals 4, y equals 4, and z equals 4, which means x equals y equals z. But wait, isn't this the same as case 1? Exactly. Trying to satisfy all second column conditions leads to a contradiction. Why? Because when x equals y equals z, all conditions from the first column are satisfied, contradicting our initial assumption in case 3. Finally, let's calculate the answer. How do we combine all the solutions we've found? We need the sum of the squares of all possible x values. Negative 10 squared, plus 6 squared, plus 4 squared, plus 11 squared. Simplifying this gives 100 plus 36 plus 16 plus 121, which equals 273. So, the final answer is 273. I've solved and published all SUMAC 2022-2023 solutions, something never done before. Whether you're preparing for advanced math programs or competitions, I offer personalized classes to take your skills to the next level. Reach out now to book your spot.